Hi guys, in this specific video we're going to look at the graphs of a trigonometric function that we call the secant function, and this secant function can be defined as the sec of x, whereby this sec of x represents the inverse of the cosine of x given as 1 over the cosine of x, as we had talked about in our various representation of our trigonometric ratios. So in this case, apart from other features that we had seen being displayed in other various trigonometric function, the sec of theta is going to display unique characteristics whereby we are going to see that in terms of intercept periods, range, and the domain, it's going to display other various aspects that we're going to pinpoint. So in this case as well, we're going to see that the virtual lines that we're going to refer to as vertical asymptotes, which are going to appear at various intervals that we can be able to describe as pi over 2 plus k pi, whereby they are going to be displayed at these specific locations that I've indicated. I'm trying to indicate on the board, and therefore we're going to have these vertical asymptotes being given at these various points which have been named. Now, one of the graphs of trigonometric functions that we had seen for the tangent of theta as well displayed this specific aspect of vertical asymptotes that we had seen at various points. So therefore, for the secant of theta, we're going to see that the domain is going to consist of all numbers except pi over 2 plus k. This is k pi, where n is going to be an integer. So if we try to look at this for the sake of this is going to be one of the condition. And one of the characteristic of these specific graphs is that they are going to be, of course, what we refer to as even functions, as they are going to obey those specific rules that we have mentioned for even and odd functions, respectively. The range of this specific trigonometric ratio is going to range between what we refer to as negative infinity to negative 1, and then we're going to have positive 1 to positive infinity given as such. So in terms of trying to visualize this, if we look at this graph for the first one, it's going towards the origin, and then along the origin along the vertical axis, and it's going to reach at a point of negative 1 and then curve there and tend towards infinity towards these 2 points that we've referred to as asymptotes. So the same case is going to appear for this second part of the graph, and they're going to of course alternate in that specific order. So if we try to compare this one in terms of cycles and try to see how we can be able to illustrate the concept of a period, we're going to see that one full cycle is going to move from this specific point and terminate at this point. And this point is the point of origin, and we're trying to see, this basically is the point of origin. If we try to consider a full cycle from this specific point, it's going to move from this specific point, and this point is going to form a full cycle of this virtual line that I've shown here. So this is going to terminate at 2 pi, which basically is going to form a period for a full cycle of this specific function for the sec of x. So in terms of symmetry, we're going to see that this is going to form an even function, as I mentioned, and it's going to be symmetrical with respect to the y-axis, as we have mentioned, of course. Now, this is one of the characteristics of the function of the secant of a function, or the secant of x, as we may refer it generally as such. So check in our description boxes for various videos which are related to this, so that we can be able to have a contrast of the same. So that is it for now, guys. Bye, God bless.